students, this is Mrs. Denton, and in this video we're going to be practicing a little bit more of SOLG 13, and this time we're really going to be tackling some problems that require more than just finding the surface area or volume or lateral area. We're going to have to do a little more thinking. Okay, so let's take a look. Our first example here says if the surface area of a sphere is 360 centimeters, what is the radius of the sphere? So this is not a direct plug-in chug. There's going to be some solving. So I've got our sphere and our volume and surface area formulas here to make it a little more easy. We don't have to go back and forth between our formula sheet and our problem-solving sheet. So here we're given the surface area, okay? We're given the surface area of the sphere. So surface area formula is 4 times pi times radius squared. But they tell us what the surface area is. So that 360 is going to go in the surface area position. And we're going to be solving for the radius. So let's see if your solving skills are up for it here. We need to get r all by itself. So I need to get rid of the 4, the pi, and the square on the radius. Well, the 4 and the pi are multiplying the radius. So to get rid of that, I need to divide. Whatever I do on the right side of the equation, I have to do on the left side of the equation. Got my calculator ready. I'm going to try and come up with an exact answer. So 360 divided by 4, the set of parentheses, divided by 4 pi. 28.6479. 28.6479. That's equal to the radius squared. Now I need to get rid of the square on this radius. And the inverse of a square is a square root. A square and a square root will cancel each other out. So I need to take the square root of the answer I was just given. Now, if I use my calculator right, I can still get a very exact answer. I need to take the square root of my answer. So I'm going to highlight my answer, hit enter, look at how it extends my answer to a whole bunch of decimal places. Now I know my answer is going to be very exact. $5.35237 is now equal to the radius. I don't know what the rounding wants. It depends on what the exact question says. I'm going to round it to the 100th. The radius will be equal to 5.35 centimeters. How do I know centimeters? Well, our surface area was in centimeters squared, and we would measure a radius in just centimeters. Okay, let's check out our next example here. A word problem. Okay. A teepee in the shape of a right cone has a slant height of 18.5 feet and a diameter of 20 feet. Approximately how much canvas would be needed to cover the teepee? Okay, so this problem is assuming that you know what a teepee is and you know how it's made. Okay, I'm going to draw myself a little cone here so I can label it. Teepee in the shape of a right cone has a slant height of 18.5 feet. Remember that slant height is the measure of the slant of the cone and a diameter of 20 feet. Well, if the diameter is 20 feet, for all my formulas I need a radius, so I'm going to write this as 10 and 10. Now my question wants to know approximately how much canvas would be needed to cover the teepee. Now, if you know a little bit about a teepee, you know that teepees have dirt floors. So we are not finding the base area. We are not finding the circle. I'm going to highlight it in blue. We are not finding the circle here below. We are excluding the circle. That's the dirt floor. We're trying to find just the fabric that's needed to make the teepee. So I'm not using the surface area here. Okay, I'm going to be using the lateral area, which is the measurement without the base. Lateral area formula is pi RL. We now know that the radius is 10, and we're told that the slant height is 18.5. I can get an exact answer here. 10 times 18.5 is 185 pi, and we're measuring in feet squared. However, I don't know if I'm going to the fabric store, I don't know how helpful knowing I need 185 pi feet squared of fabric is. I probably need a rounded measure. So I'm going to go over here to my calculator and find an approximate value. 185 times pi is approximately 581.195 feet squared. I think that's probably the better answer. However, the exact answer is right also. Okay, let's check out our next problem here. This is a pretty popular problem on the good old SOL. It says the volume of a cube is 64 centimeters. What is the surface area of the cube? Now, this is not an image from your formula sheet. This is what we discussed on our very first video in this section about how to find the surface area and volume of a cube. So I've copied it over here for our use. It says the volume of the cube is 64 centimeters. What is the surface area? Well, if all we know is the volume, that's what we have to start with. 64 can go in the volume spot. Now the only thing for me to solve here is the side length. Well, we don't run into a cube very often in geometry. We normally are running into a squared value, and to get rid of something squared, we take a square root. So to get rid of a cube, we need to take what's called a cube root. A cube and a cube root are inverses of each other. Essentially, we're saying what times itself makes 64. If you need a little help with that, let me show you where this is in your calculator. There's a little menu button right beside the 9 on your calculator. It has several options. And on the top row, fourth over from the left, is the option we need to take the cube root. We need a 3 in the small box and 64 in the box beneath the root. And I get 4. So the side length of this measurement is 4. So now I can take that over here to the surface area formula. The question is, what is the surface area of the cube? The surface area calls for 6 times S, which we now know is 4, squared. 6 times 4 squared is 96. Now, we started with a cubic measurement, but we're ending in area, so we're ending with a squared measurement. The surface area of the cube is 96 centimeters squared. Okay, Our next example here is another word problem. It says a rectangular swimming pool is being filled at the rate of 12 cubic yards per minute. If the pool is 6 yards long, 4 yards wide, and 2 yards deep, how long will it take to fill the pool? Okay, let me give myself a little picture. It says it's a rectangular pool, so it's going to look a lot like this. So let's see if I can draw this here. Not too shabby. It's fine. Okay. A rectangular swimming pool is being filled at the rate of 12 cubic yards per minute. If the pool is 6 yards long, 4 yards wide, and 2 yards deep, how long will it take to fill the pool? All right, so first things first, I got to figure out what I'm doing here. What does it mean to fill the pool? Am I looking for the surface area or the volume? Well, to fill something, I'll be looking for the volume. So the volume of this pool is equal to the length times the width times the height. I'm going to say 6 is the length, 4 is the width, 2 is the height. 6 times 4 is 24, and 24 times 2 is 48. So this pool has 48 cubic yards of water in it. That's the volume of the pool. Now the question wants to know how long will it take to fill the pool? Okay, the information says the swimming pool is being filled at a rate of 12 cubic yards per minute. 12 cubic yards per minute. So at 12 cubic yards per minute, 12 times how many minutes will it take to fill the pool to 48 cubic yards? I'm going to divide by 12. 48 divided by 12 is 4. So we're saying this pool is going to be filled in 4 minutes. Holy cow. That must be filled with a hose from the fire department or something. All right, one final problem to work through here. All right, in this image, it looks like we have a cone sitting on top of a cylinder. Cone sitting on top of the cylinder. Well, it says, what is the surface area and volume of the following composite figure? That just means that these two figures have been glued together, okay? This is definitely going to take some thinking to do. Let's look at the surface area formulas here. We got the surface area formula for a cylinder and the surface area formula for a cone, okay? Well, in our figure, looking at the cylinder, in our figure, there's something missing on the surface. Look over here. There is a base on the surface. There's the wraparound on the surface, but this upper circle is not on the surface. So I have to somehow manipulate the surface area formula of the cylinder to exclude this upper circle. So I really need to know what this formula says. This says 2 pi r squared. Now, pi r squared, going up to the very, very top, pi r squared is the area formula for a circle. So this says I have 2 circles. Oops, excuse me. This says I have 2 circles, but now I know I only want 1 circle for the surface area. This 2 pi r h is the lateral area, so that's the wraparound. So the surface area for this shape, I'm going to manipulate it a little bit. I don't want 2 pi r squared. I want 1 pi r squared plus the wraparound, 2 pi r h. I just want this bottom circle, not the top circle. So I don't need 2 circles. I just need 1. The same thing is true up here on the cone, okay? On this cone. The base of the cone is not on the surface. The base of the cone is not on the surface. So I don't want a formula that has the circle base in it. I want the part of the formula that's just the wraparound, which is the lateral area. Lateral area of a cone is pi RL. Once I find these two values, I can add them together to get the total surface area. All right, so let's see what we've got. Lateral area. Pi times the radius. Well, it looks like our diameter is 24, which means the radius is 12, times the slanted height, which has been given to me as 13. Exact value. I'm going to work in exact values. 12 times 13 is 156. So my exact lateral area is 156 pi feet squared. Now I'm going to work on the cylinder part down here. Pi, 1 pi, times the radius, which is 12, squared, plus 2 times pi times the radius of 12 times the height of the cone, which is 10. 12 squared is 144, so this is 144 pi. 2 times 12 is 24, and 24 times 10 is 240 pi. And 144 plus 240 is 384 pi feet squared. So we've got the cone's surface area, and we've got the cylinder surface area. I need to take these two values to calculate the total surface area. $156 pi plus 384 pi. 156 plus 384, 156 plus 384 is 540. 540 pi feet squared is my exact value. For a rounded value, of course, I go back over here to my calculator and multiply 540 by pi. $1,696.46 feet squared. Whew, all right. That was a lot of work for the surface area. The volume is much less work. Make some space here for the volume. With the volume, we're talking about how much space fills up this composite figure. Well, if you broke apart these two figures and filled them up, it would be the same as putting the two figures together, because we're talking about the space inside the figures. So I don't need to manipulate the volume formulas as I had to manipulate the lateral or the surface area formulas. So here I am on my formula sheet. Volume of a cylinder is pi r squared h. Volume of a cone is 1/3 pi r squared h. So the two volumes together will be pi r squared h for the cylinder plus 1/3 pi r squared h for the cone. All right, let's see. Plug everything in. Pi times 12 is my radius, 10 is the height, plus 1/3 pi, 12 is the radius, 10 is the height. 12 squared is 144. 144 times 10 is 1,440 pi. This would be the same 1,440, but I've got to divide that by 3. Let's use some calculator work here. 1/3 times 12 squared times 10. There's my 1,440 divided by 3. That's 480 pi. So now I need to add them together. Plus 1,440. Total volume 1,920 pi. And remember, when you're talking about volume, you're talking about cubic measures. Cubic measures. If you want to turn that into a rounded figure, all you have to do is multiply the two together. 1,920 times pi. Approximately 6,031.86 cubic feet. All right. Let's get everything highlighted so it's easy to find. All right, so total surface area, we've got our exact measure, we've got our rounded measure. Total volume, we've got our exact volume and our rounded volume. Thanks for working out these tough problems with me. This concludes our video series on SOLG 13. Happy studying!